Dear children, welcome to the YouTube channel H2O Chemistry. Today we are going to learn another important and interesting topic called relative atomic mass, simply called RAM. What is meant by relative? So the relative means comparing with other elements. So we are going to see the relative atomic mass. So comparing with other elements, what is the mass of an element? So we are going to check. Now, the atomic mass of an element relative or compared to the mass of atom of other element, so that the mass can be easily identified. I hope you understood this. So let us go to the example. Just look at this pen, children. Let us say the weight of this pen is 1 gram. I have another two similar set of pens. Okay. What is the weight of this pen? You will immediately say 2 grams. But I'm going to use a different word. These two pens are 2 times heavier than this pen. Alright? Come to the next idea. If I have 3 pens, this set is 3 times heavier than this pen. If I have 4, what did you say? Yeah, this set is 4 times heavier than this pen. Am I right? So it's in comparative value, right? So if it is a 1 gram, you will say 4 grams. I can say this is 4 times heavier than this. That's what you have to implement here. So what scientists have done is, they have taken a similar vessel so that the volume is constant. So they fill different elements in this. The first one oxygen, second one hydrogen, nitrogen, chlorine. They weighed it. The mass is nearly, the mass of oxygen is 32, hydrogen is 2, nitrogen is 28 and chlorine is 71. Further they divide by a common number. So they have got the final number 16, 1, nitrogen 14, chlorine 35.5. Which is very least. So hydrogen. So they take it as a standard. So it's just not arbitrary value, just comparison they have taken. So 1. Now what is an oxygen value? It has got 16. So can I say like this? Oxygen atom is 16 times heavier than hydrogen. Right, as I said before. So oxygen atoms are 16 times heavier than hydrogen. So the relative atomic mass of oxygen is 16 in hydrogen scale. Similarly, come to nitrogen. In this method, we have got the value 14. So the nitrogen is 14 times heavier than hydrogen. Similarly, chlorine. This is 35.5 times heavier than hydrogen. Right? So this is called relative atomic mass. So we are comparing, we will take one atom as a standard. Another atom we will compare. The mass of other atom will be comparing with this atom so that the mass can be calculated easily. I hope you understood this. So let us see some standards. The scientists have used various standards depending upon the time. Now the first standard was hydrogen. The reason is it is a very lightest element. And what are the drawbacks? After the existence of isotope of hydrogens, the atomic mass of hydrogen is not exactly equal to 1.0. It's not 1.0. So the mass is somewhere near to 1.008. So nowadays they didn't use this standard, used as a standard. Now come to the next standard, oxygen. The reason is it reacts with most of the elements. That's why they have chosen oxygen as a standard. But later they come across the problem, again the existence of oxygen. There are 3 isotopes and the atomic mass average atomic mass is not exactly equal to 16. So for these drawbacks, they withdraw this oxygen. Now come to the third standard. Nowadays we follow this carbon-12 isotope. We are not simply saying oxygen. We are particularly specific about the isotope, carbon-12 isotope. The carbon has a 3 isotopes, 6 carbon-12 and 6 carbon-13 and 6 carbon-14. We are not talking about these two isotopes. We talk about only this isotope because in the nucleus it has a 6 protons and 6 neutrons, so the mass number will be 12 exactly. That's the first reason we have selected for this. Next, the existence of carbon-12 isotope is nearly 99%. Yes, the other two isotopes are available only in the living things like plants and animals. Got it? You might have come across the CV14 is a radioactive isotope. So largely this, I can say almost 100% this carbon-12 isotope exists in the atmosphere. So if we take this as a standard, the calculation will be easier and tidy. That's the reason they have chosen this as a standard. Now let us go to the next one. How do we calculate radioatomic mass? Now we know very well that atoms are amazingly small. So their mass is definitely very, very small. So if you weigh the atoms in the electronic balance, we will get very, very silly answer. I guarantee there is no such electronic balance to measure such a small mass. So the mass of an element is compared with the mass of atoms of carbon-12 isotope. So that's why I said earlier, comparative it is. So they'll compare with one element, they will find out the mass of other, right? So what they have done, the carbon-12 atom, they have divided into 12 equal parts. Why? I'll explain this why. Why do we say 1 by 12th of mass of one carbon-12? Because why do we divide a carbon atom into 12? So that one part we consider as 1 AMU, 1 U or 1 unit. Why? Because in the carbon scale, which is the least value, that's what we have to identify. Let's compare this. An atom of magnesium 12 Mg24 weighs twice as we compare to carbon-12. Yes, you're right. Look at this. The carbon mass is 12. The magnesium mass is 24. Definitely, if you multiply by 2, we get this 24. So that's why we say an atom of magnesium weighs twice as we compare to 12. Look at the hydrogen. An atom of hydrogen is 1H1, weighs only 1/12 of that carbon-12. Right? So carbon-12, the mass when you compare, it is 1 by 12 of mass. So what is the basic unit here? 1 by 12th of mass of carbon-12 is mass of hydrogen. That's why the basic unit we say. So why do we say 1 by 12th of mass of carbon-12 atom? Because in the carbon scale, the least atom has the mass of 1 by 12th of mass of carbon-12. Let us go to the next example, that is lithium. Pre-lithium 7. Atomic number is 3, mass number is 7. So the 7 is the mass of lithium as per the scale carbon-12. So what we have understood, very simple. One atom of lithium is 7 times heavier than 1 by 12th of mass of carbon-12. Hope you have got this. Right? Let us go to the next example. Let us take the case of sodium. So the mass number is 23 on the carbon scale. So, very simple idea. 23 times the sodium is heavier than 1 by 12th of mass of one carbon-12 atom. Right? Now, let us go to some more informations. Go to definition of that. So what is meant by relative atomic mass. It's otherwise called standard atomic weight. It's simply denoted by AR. Now, what is this? It's a ratio. We are comparing with carbon 12. 1 by 12th of mass of 1 carbon 12 is otherwise called 1 atomic unit, or simply 1U. So the average mass of isotope of an element divided by 1 by 12th of mass of carbon 12. So this is a ratio, right? Let's take if the sodium mass is 23. What is 1 by 12th mass of carbon 12 atom? 23U divided by 1U. So the mass of sodium is 23 in the relative scale. Similarly, the other formula is average mass of an atom divided by 1 AMU or unified atomic mass. The same we can use, either one you can use. So it is a pure ratio, right? So for sodium, 23 is the average mass of isotope of an element divided by, as per the carbon scale, 1U. So this will be cancelled. So there is no unit. Hence it has no unit. Now, so it is a pure ratio. If an atomic mass of an element is expressed in grams, so I'm going to show you some of the other atomic masses, so you'll be very familiar, easy to understand. So that, look at this. All this 20 elements are based on the scale carbon 12. So carbon 12 scale, as per this only I have given these numbers: 4, 7, 9 for beryllium, 11 for boron, 12 for carbon, 14 for nitrogen. So I can definitely say nitrogen is 14 times heavier than 1 by 12th of mass of carbon 12 atom. So we are comparing it. So it's worth knowing. So if we express this relative atomic mass in grams, it is called gram atomic mass, otherwise called simply GAM. So the gram atomic mass of hydrogen. So atomic mass of hydrogen is 1. So gram is 1 gram. Gram atomic mass of carbon is 12 grams. Gram atomic mass of nitrogen is 14 grams. So it's a very simple idea. We have to replace U by G. That's all. We will get the gram atomic mass. Alright. So nowadays the determination of atomic mass can be done by the method called mass spectrometry. See, this idea, okay, I'll give you as a next video. Thank you.